Introduction to Flume. Hi, welcome to this Big Data and Hadoop session with Acadgild. In this session we are going to talk about Flume, the important log aggregator component in the Hadoop ecosystem. Introduction. Flume has been developed by Cloudera, and it is essentially a tool which aggregates data or logs from different machines and places them in the HDFS. To work with MapReduce or other processors, we assume that data is present in the HDFS, which might not be the case at all the times. Sometimes data can be produced from different sources, like a web server or a file server, and then we must bring data into HDFS first before we can process it. Flume is a tool which helps us achieve these functionalities, such as aggregate, store, and analyze using Hadoop. Flume is designed to perform high-volume ingestion of event-based data into Hadoop. As of now, we can assume that one event specifies one message which is going to be ingested in the HDFS. And once we bring the data to HDFS, we can then perform our own analysis on top of it. Flume is easily integrated with other ecosystem components, including HBase and SOLR. Let's discuss some important concepts before moving towards hands-on examples. There are certain important concepts that we should know before moving towards hands-on examples. First of all, there is a Flume agent, which is a long-running Java process. This is the agent which checks for new data and then transfers the data to the destination, which is usually HDFS. One Flume agent has got three important components with which it is connected to. The first one is the source. The other is the sink, and finally the channel. As the name says, source is basically the producer of data, whereas sink is the destination. It is the consumer of the data, and finally the channel is the entity in which data is stored on a temporary basis. So it's a passage between the source and the sink, which connects both source as well as sink. And ultimately, Flume is the agent which is connected to all of these three, that is source, channel, as well as sink. The installation of Flume is very easy. Just download the binary file of the Flume available on its website. Once it is done, export the Flume home and place it in your path variable. At this point of time, we won't bother about Flume installation because we will be using a Acadgild sandbox, which comes with pre-installed Flume for us. In order to start working with Flume, we have to start a Flume agent using the syntax starting with Flume-ng. Flume example. We will look at the Flume architecture along with its working with the help of an example. The example is to show the file virtual concept, or say, as a spool directory. We must set up one environment where we are watching a local directory for new text files. The directory in the file system where some new data files are received. As soon as the new file arrives, we should send each and every line of that particular file to the console or to the HDFS. That is something which is dependent on our requirement. First, we are going to work with the configuration file in Flume, which is essentially a property file. In this example, we will create an agent whose name will be Agent 1. But you have a privilege to choose a different name of your choice. The different components should be attached to this agent, including the source, sink, and channel. Using agent1.sources, you can specify the list of sources in the space delimited manner, and accordingly, you can also specify name for channel and the sink. In our example, we will name source, sink, and channel as source 1, sink 1, and channel 1, respectively. Also, you can choose different names according to your requirement. Flume Architecture. This explains the architecture of Flume. Suppose there is a directory in the local file system whose name is /tmp/spool_dir. It can be different directory also. In this directory, files are coming at periodic intervals. First, spool_dir source will check for the arrival of any new files at this directory. It will pass the events, which are essentially the messages, to the file channel, and this is one transaction of sending the data from source to the channels. Once data is sent to the channel, then events will be moved to the sink. The sink can be a logger sink or it can be HDFS sink depending on where we want to place our data. If it is a logger sink, then data result will be displayed on the screen. If it is an HDFS sink, then data will be moved to the HDFS location. This combination of source, channel, and sink is called as an agent, and basically it is connected to all three. Let's take a look at how the configuration file looks like. Coding spool_dir.conf. The configuration file is essentially a Java properties file. With Agent 1, we specify sinks, sources, and channels, like what are the different names. Channel is a temporary storage of the data. In this, you can have a file channel or you can have a memory channel. If you're having a memory channel, then there is a higher throughput, but a compromising durability, because if Agent restarts, then you will lose all the content of the memory channel. If you have the file channel, throughput will be slightly compromised, but it will give you a better durability. So depending on the importance of data, you have to make a choice between these two channels. Either you are going for file channel or memory channel. The channel type of file is specified based on the two important configuration on the channel called capacity and transaction capacity. Just recall, we have discussed that there are two transactions involved in the Flume. First, the data movement happens from source to channel, and the next is from channel to the sink. So, transaction capacity specifies the number of messages that can be transferred in a single transaction, and capacity specifies the number of messages which you can call as events that can be stored in the channel for temporary and intermediate purpose. The type of our source is spool dir, which is like a file watcher, which we have specified previously. The location of that particular spool dir can be your own location, so this directory in a local file system will be investigated on arrival of new data. There is few more information like file header and file suffix. Essentially, there are two things under spool dir, which is the header and the other one is the value. File header may contain information like timestamp of the message and other detail. We don't want header, rather we want only the message. Once the file has been transferred or been picked up from the spool dir, the name will be modified and .completed will be appended to the end of the file. This makes easy for Flume to identify which file has been transferred. In our case, type of sink which we are working on is HDFS, and there are few more configurations on the sink. First of all, path. This specifies which is the location of the HDFS where data will be returned to. Sometimes it is important to use batch size of a file because you don't want to send the message one by one. Sending a line-by-line message every time may consume longer time. So we combine them in batches, and one batch in this case will contain 1,000 messages. Once the size of the data in the HDFS file increases, these particular bytes will be rolled and a new file will be created. New file will be created by providing some more information like a roll count and roll interval. Roll count specifies the number of messages in the HDFS output file. When the number of messages in the HDFS output file crosses a defined value on the right-hand side, then a new file will be created. Roll interval specifies the duration of time a new file will be created in the HDFS. If the roll interval is set to 0, then it simply means that we are not going to roll the file on time basis. Whichever of the following options, such as roll size, roll count, or roll interval, happens first, a new file will be created in HDFS. This will be explained with help of an example. The type is data stream because it contains a stream of data. The resources such as source and sink are specified with the channels called file channel. This is a file channel is going to be placed in our virtual machine. So I am going to use a Acadgild virtual machine for our purpose. And there we are going to have the file, which is the spooldir.conf. In order to run that particular file, we're going to launch the agent using this particular command. This is flume-ng agent-n agent1-f spool_dir.conf. The agent-ng means the name of the agent, and -f means the name of the configuration file. If we run the above command in the CentOS window, you will see list of log on the screen, and finally a message saying that yes, your source, channel, and sync have started. So in log you will find that the source, sync, and channel are all started. Now let us see what happens. Let us go to the location where we have identified our Flume spool dir. Now let's copy the location and go to the same location. Once we go to the specified location, let's see what the content is. As of now, there's no content stored in the mentioned location, and this is similar to location of the HDFS sync. Let us check this particular part as well and make sure that all the processes are running using JPS. If they're not running properly using JPS, then you can execute the command start-all.sh to start those services. Now we're going to see what is the content of the HDFS location. That is /flume_sync. As of now, there is no data present in the directory. Rather, the particular directory itself doesn't exist. In this case, let us create a file and name the file as file1.txt and add some content like line 1 of file 1 and write line 2 of file 1 respectively. After performing these steps, save the file by typing ;WQ and exclamation. If you type ls-lrt, you will see the name has been changed and .completed has been added. In the running Flume agent, you will also see the message that a particular HDFS directory has been created. Now, let us see the same in HDFS location. If you want to see the location flume_sync of HDFS, you will observe that a particular file has been created. First, let us see the content of that particular file. Now, you will get to see that the data content in the file is same as the data we written in our file 1.txt. That is, this is line 1 of file 1, and this is line 2 of file 1. As soon as a file is created in the spool directory, location of that particular messages of the file gets transferred automatically behind the scene to the HDFS. So this is one example where log aggregation happened. For more understanding on this key concept, let us create one more file named file2.txt, and let us add 2 lines similar to the previous example, like this is line 1 of file 2. This is line 2 of file 2. And let's add 2 more lines here. This is line 3 of file 2. And finally, this is line 3 of file 2. If you want to save the file type, then ;WQ and exclamation. If you execute ls-lrt command, then the file name has also been changed and .completed has been added. If you want to see the content of the HDFS sync location, you will see there is 1 file and added with 1 more file in the list. So basically the file has been rolled over because the roll count was 5. So 1 file cannot contain more than 5 records. Let us verify the same. Now type Hadoop fs-cat command and then paste the first file. you will see it will contain only the first 5 messages, which is called the 5 events. And any new event apart from these 5 events will go to the next file location. Now let us verify. As of now, we have produced 6 messages, where 2 messages from the first file and 4 from the second file. The first 5 messages have gone to this particular file, and the last message has gone to this particular file. That is the last message. This is a line number 4 of file 2, is saved in the second file. So this is all about Flume, which acts like one local file system directory and a spool directory. You can also work on many other things with the Flume, such as taking logs from Twitter and more web server logs from the distributed environment. Thanks for watching this video. Stay tuned to Acadgild videos to know more about Hadoop ecosystem components.